Welcome to Alabama A&M University. This is a conversation that we're having around FICO's Educational Analytics Challenge. I recently spoke with Bowie State University, who just completed the challenge as well, and I'm really excited to talk to Alabama A&M about their perspectives on the program also. FICO is proud to partner with Alabama A&M, and we congratulate you on completing the challenge. I want to dive into your approach, but first, I just want to recap for everyone that's watching, what is the FICO Analytics Challenge? This FICO Analytics Challenge is the first ever FICO college program that presents students with real-world practitioner challenges to prepare them for data science careers in financial services industries where firms are operationalizing AI, analytics, and machine learning and dealing with and grappling with the real problems with working with data today. This year's challenge problem is one of those biggest problems. It's around identifying and mitigating bias in data and looking at the subsequent models that we derive from using this historical data. This year, and for this program, we used historical lending data collected by the CFPB as part of the Home Mortgage Disclosure Act and provided that to the students so that they have a chance to explore the complex and life-altering decisions that data science models can make. They broke into respective teams and they focused on concepts of responsible AI, trying to make sure that as they work with this data and build models that they have their own sort of experiences with trying to protect and safely advance analytic practices. The Alabama A&M students had the opportunity to be mentored by myself and my team of data scientists throughout the semester-long challenge. And I've invited a few of them here today to discuss the program. I want to thank Alabama A&M faculty members, Dr. Pearson and Dr. Zhao, as well as the two of the three students from the first place team, Team 3, DeQuandalyn Daniel and DeTavein Walker, for joining us today in this conversation. Let's dive in. So first, Dr. Pearson, thank you so much for joining us and having this conversation. I wanted to really just first start with, tell the audience your role at Alabama A&M and why you chose to participate in this program with FICO, providing this opportunity to students.
So thank you, Scott, for giving me the opportunity to have this conversation today. And so I want to thank you so much. And so I am an assistant professor in the College of Engineering, Technology, and Physical Sciences, and I am in the Electrical Engineering and Computer Science program. And we thought it would be very beneficial for our students to take part in this type of challenge because it gives them the opportunity to culminate their skills that they've learned throughout the semester and throughout their college career from the different aspects of not only just computer science, but also the other courses that come from the general curriculum as well.
Got it. And you know, it's interesting, you know, I speak with a lot of colleges and, you know, very often, you know, students don't have access to real life data, right? And I think, you know, that was probably one of the things that was new and interesting, maybe for some of the students to kind of work with this type of data and, you know, and put all that education to use, right? To get outside of the academic realm and into like, okay, let's apply those techniques. So very exciting. Dr. Pearson, with your guidance, right, the students broke into teams, and I think this is one of the more interesting parts of how Alabama A&M approached the problem was that there were 4 teams, right, and they were competing, right. There were, you know, the first place, and there were prizes for different rankings here, and I thought that was brilliant, right. It allowed for different teams to explore the problems differently, and showed, you know, diversity of thought and how they would approach the problems. And also just allow them to learn from each other as they work with the data. So I was curious, you know, what inspired this sort of, you know, breaking into teams, and what did you see yourself as you mentored and monitored these teams in terms of the approaches they took as they first started this challenge, working to identify bias in this Home Mortgage Disclosure Act mortgage data?
So we chose the competition approach because we are in the process of incorporating data science into our curriculum, and currently we only offer one course. And so doing the competition allowed us to incorporate this into our curriculum, and not interfere with the students' current coursework. And so we identified a group of students that were interested in participating in the challenge, and we allowed the students themselves to break off into teams. And so we had an even number of students, and so that worked out to us having about 4 teams, and there were about 3 students per team. And so our students are very competitive, and so they right off the bat they wanted to make sure that their intellectual property or their what they discovered would not that their partners or the other teams would not have access to. And so we worked so to ensure that the teams were isolated as they worked through the solution. And so the students all had varying backgrounds because we had students ranging from the sophomore level all the way up to the senior level on the project.
How did they self-organize? I mean, were they all, they knew each other from classes and they were friends, or were they, I mean, given the competitiveness here, were they very strategic? Like, I need a Python person on the team, and I need, someone that has a broader soft skills, or how do they, were more familiar the way they broke into teams as they tried to address this?
So the students who participated, some of them have competed on in like pitch competitions in the past.
Okay.
And so they kind of chose their partners based on those who they've worked with in the past, and like you said, based on their strong suits. And so some students had more skills when it came to Python programming, whereas some was more on the research side. And then we also had students who felt more comfortable with doing the verbal, or like you say, the speaking components. So they paired each other based on their strengths.
Got it. Well, I think the competitive nature was great, and looking at what all teams produced, right? All very different perspectives, and there were some things that were similar, but there were insights, across that were different, and I think that was probably a really good exercise in some sense, just to see that the different thoughts that come out of it. So some of the feedback I've gotten with the challenge is that, this is real world data, and we did prune it down, but it was still large and it was still complex, and we didn't clean it for the students, right? We said, okay, let's make this as real as possible. And so it was, we had missing data. They had to deal with things like how to deal with the, co-applicant and applicant gender, and missing values there. So like they jumped, right into the deep end, right? There was no waiting around in the shallow end here. How did they deal with those complicated concepts? And when they first approached the challenge, was that a challenge for some of them? What was your thoughts?
So so the students also, like I said earlier, the students had varying skills, and so we had various majors participating. So we had a wide range. So we had CS majors, we had electrical engineering majors, and we also had some civil engineering majors on the project. And so they all brought a different skill set, and when they first got the data, they were overwhelmed, like you say, with the size of the data. And so their first task was to just get familiar with the data, understand it, and make sure they went through the data dictionary and understood the labels as associated with the different entries in the data set. And so going after that, their next steps were, after they understood the data, to try to see like you say, they identified the missing values, and then they wanted to figure out how to deal with those missing values. And then from that they looked at how they were going to code the data so that they could analyze the data.
Got it. And I had the great pleasure of visiting campus, and I appreciate you were a tremendous host, and I gave a talk there around responsible AI and ethics and some of these challenges. And I'll tell you just my impressions meeting with the students. They were a serious bunch, right? They were already asking questions about how to deal with missing value imputation, and many of them have looked at for example, the teams here were looking at SMOTE and other sort of approaches here, and so they were all business, and that was great. I mean, we had some conversations about career development and what it means to kind of be in this sort of field, but a lot of them were task at hand, and I really I was kind of inspired by that. They were really trying to focus down on how to work with that data. Even when I visited midstream, they were very serious there. So from your perspective, what learnings or maybe changed perspectives do you think the teams came away with? One of the things that I think is really interesting is that, we want to have a very honest sort of conversation about the fact that all data is biased, right? And the societies we live in are biased, and data gets reflected in that. And I tend to say when I travel the world that, data is essentially a liability, right? So when we build models with it, we can try to correct for bias. We can also just inspect the models and test that they're not biased. But it's a tricky business, right? And I think it's really important to get new perspectives and allow students to have their own sort of chances, right? To go and explore different ways of addressing bias or detecting bias. So what do you think the students came away with overall, right? We'll talk to Team 3 and see what they think, but what do you think they came away with in terms of, do they have a better appreciation for data bias? Are they maybe armed with the skills to attack these as they move on in their careers?
So I would say overall, all of the students took away, their main takeaway was one of your key points, that all data has bias. And another key takeaway that they took away was a point that you made, that while mitigating the bias, you may be indeed causing bias on another group or another portion of the data. Also, the students learned different tools as well as software tools and platforms that they could use for data analysis and cleaning of data. And so the students also learned that this was a career path that they could take outside of the traditional software engineering career path. And so additionally, the students, I would say their main takeaway was that I would say that the students' main takeaway was that they needed to be in these roles so they can help prevent bias throughout the data, the process of acquiring data, analyzing it, and all of that. They wanted to make sure that they are in these roles and taking part in the conversations to help mitigate the bias in the whole data process.
That's awesome. And I think you mentioned, like, addressing bias in one group could inadvertently cause a bias in another. And I think this is one of the more complicated aspects of trying to work through this, right? It's like walking against a current, right? It's really tough, right? And I think they come away with the skills, they come away with the experience, and as they move on in their lives, they're gonna see this repeatedly, right? And if they're advocates for their communities, they're advocates for the problems that they work on, bringing those perspectives in are super important. So I saw a lot of great thought and a lot of maturity in the students in terms of how they approached it, and I can't wait, right? They're going to be the ones that are going to help address this problem over the years and incrementally make, improvements here. So that's great to hear, Dr. Pearson. I definitely, appreciate your support with the program and mentoring these students. They all did tremendously well. With that, let's talk to the winning team, Team 3. So let's get them on. Okay. So Team 3. So we have 2 representatives here from our winning team, Team 3, and I think you all spent more time on data science than creatively naming your team, Team 3. But that wasn't part of the success criteria or how we evaluated the winners. So Team 3, you're 2. We have DeQuandalyn and DeTavein here representing the team. We also have a third, Jerusalem, that is not on right now. And I want to thank you for joining me to discuss your experiences. It's super important for me just to get your perspectives and for me to learn from you and the rest of your colleagues on these teams. So first, I want to congratulate you on getting first place. And I want to ask you a couple questions right off the bat. So we heard a little bit from Dr. Pearson. Your Team 3. I remember you, Team 3, as one of the teams that were asking some really specific questions about how to work with data when I visited Alabama A&M, and it was really impressive that you guys were all business, and I really appreciated that. So can you explain how your team decided to approach the data science challenge? I mean, maybe DeQuandle, maybe you can take that one and say, you drop this data and you drop this problem statement. It's not a little one, right? The problem statement was essentially take this Home Mortgage Disclosure Act data, find the bias, address the bias, build better models. I mean, that's a big job. So how did the Team 3 first approach it, DeQuandle?
So the first thing that we tried to do, we tried not to, just look at it as, hey, we got this data set and we want to code this out and figure it out. We kind of, wanted to break it down in smaller steps. So we wanted to understand the data set first. So, y'all gave us the data dictionary. So we kind of went through the data dictionary and made sure that we understood all the fields and, what was going to be in that data set. Then we looked at the data set to see what we actually had. And once we were able to look through the data set, we were able to, identify what columns had missing values, what columns may have some repeated values. So, just breaking it down into, smaller problems instead of looking at one bigger problem really helped us, be able to overcome and be successful at the project.
Love it. So breaking, getting the lay of the land, breaking it into pieces and just, figuring out, how to approach it. And I think that's the right approach, right? A lot of things are overwhelming, so you take it a bit at a time. What were your initial impressions? Maybe this is for DeTavein. When you're confronted with this data set and then, you got the lay of the land, you understand kind of what's in the data, what's missing. What were your first initial impressions as you were trying to detect and mitigate the bias so that you could improve models?
We initially wanted to put the data into an easier way to understand it, because just looking at the Excel, you're like, just a lot of numbers on the screen. So we put it into tree maps and heat maps, so that way it could colors, like the darker the color is, the more population of that specific column is in there. And so once we got those heat maps and tree maps made, we were easily able to detect there's a trend right there. That could be a bias right there because of how much population is in that specific column.
Got it. Yeah. And that's important, right? I mean, just, we don't talk about it all the time, but, BI, right? Focus on essentially analyzing that data, getting insight and looking for those trends is a great way, right? A lot of data science is boiling it down to some simpler sort of behaviors in the data, so you can then decide how to attack it further. Okay, so then we got the lay of the land. We understood, the data. Then we put in within visualization tools and heat maps, and we started to see differences in groups of individuals, or maybe how fields were correlated with approvals in this mortgage data. What was the most interesting part of exploring data bias and how to mitigate it? Or maybe was it just overwhelming? And maybe DeQuandle, what were your thoughts? I mean, you explored a lot in Team 3 as you started to look at these heat maps and look at the data. What do you think was most interesting that you came away with as you started to try to, figure out, out of all the bias, and there's more than one type of bias in that data for sure. What was the most interesting parts for you?
I think the most interesting part for us as a team was, to choose what bias we wanted to attack. And we chose to attack the bias that was in our categorical columns. So, our race, ethnicity, age, and some of those columns. And one thing that we also found interesting is that depending on what you want to do is always, different techniques and tools that you can use to attack that bias. We chose to use smoke, but we could also use, undersampling, oversampling, and some of those various bias mitigation techniques. So, just that it was, different techniques to use to tackle what we were trying to do. That was the most interesting part.
Yeah, no, that's great. And I love that, your team and yet another team both use SMOTE as one of the approaches, right? To look at some of the underrepresentation of different groups, right? And so most definitely, right, to make, representation bias is a big issue, right? And to make sure that the model doesn't bias itself towards, let's say, a majority class, right? Looking at how better to balance that so that the model can learn all behaviors in equal ways or do the best they can is super important. But you're absolutely right. There's a whole bunch of work. And, this is where data science becomes a little bit about, data art, right? Because you get experience with using a technique, you have success, and, part of that comes with experience, right? And part of that comes with, different exploration. DeTavein, as you looked at this bias, the team eventually came up with a revised model, right? You had an initial model, and you all had a revised model. That revised model, you showed the statistics. I think you improved on all classes, and Team 3 produced what they believe to be a better model, right? But not a perfect model, right? And so I was curious from your perspective, DeTavein, how do you think about it after all this work? And the team did a ton of work, right? But was it? Do you think this is something that we solve, or is it something that gets codified into a strategy or incremental set of steps where we eventually get to a point where the models become less and less biased and data becomes less and less biased? What's your thoughts just working on that program, the program as it is, and with that real world data?
I would say that eventually there will be a way to get it to where there's very little bias, but with the discrepancy between the population of minorities and Caucasians, there's a big discrepancy because the population is so different. So it would be very hard for AI to completely delete that bias. But with the techniques and the smoke, we got our model to very accurately, or not very accurately, more accurately produce a better prediction. So it will possibly in the future, with more effort put onto it, get it to a point where there's very little. But as completely eliminating it, I don't think that would be possible because there's always going to be that discrepancy.
Yeah. And this is this is one of these facts that we all have to try to evolve past, right? But from my perspective, and I think I even shared this, when I was visiting Alabama A&M, sometimes, people think about, these incremental changes, right? Because it does take a while to just kind of provide that opportunity to others, right? And to get more data and to build more fair models, and incrementally get there is probably, a right approach versus, a foolproof, single shot, right, is probably unrealistic given some of the bias that is, readily apparent in that data, right, as you mentioned, DeTavein. But getting to a model that incrementally improves over time and having a program, right, this is why, having a program of how you use it is so important, because it allows us to kind of, intentionally try to address, and over time it gets better. Okay, so for me, personally, right, it's a pleasure to work with Alabama A&M and the teams there, and it's important to FICO also, right, to train a diverse group of students who, frankly, gentlemen like yourselves are going to, drive the future of AI innovation and responsible AI practices if you choose to continue in this field of data science, and some of your other colleagues in this program, the same for them. And I think this is one of the interesting items, is just to get exposed to these problems where you are today, so you can bring that out to whatever work you end up doing. So, maybe switching to maybe more of a futuristic view. This is for both of you, right? How do you plan to incorporate these skills into, you learned during this FICO Educational Challenge throughout your careers as you see them right now?
I think for me, it just made me more educated and open to discrepancies that you would you see in data sets and things like that. It was just an article that came out yesterday where it was a certain bank, and black families that made it $140,000 compared to white families that made almost $57,000. The black families were actually approved less for actually home loans. So it's actually a real world problem. I mean, you see it all the time. And I come from a software engineering background. So just knowing that some of these AI models exist like that, and that even in the real world that they're not overcome bias mitigation, I think it just made me more open and, more aware of what we can do in the software engineering world to make sure that these problems are. And I'm sorry, did that cut me off?
No, you're good. You're good.
Okay, hold on. Give me a second. I'm so sorry.
No problem. So absolutely, right? I mean, I think we see examples of this all the time. So, right, this is one of the things I think that's important with the challenge is just an opportunity to kind of, be part of a solution, right? And I think, as you said, DeTavein, focusing on using software engineering and data science to kind of automate and improve these models is super important. And deriving those tools to make it visible, right? Because very often it's just ignorance or lack of the tools to expose. And once we have those in place in a process, maybe we'll see less and less of those things in the news. DeTavein, what's your thoughts?
I would say this data science project definitely taught me to never give up. It was a stressful project. I learned how to code in Python. Like making the AI model was probably like the best thing I've done the whole semester. It was pretty cool. I would say that I definitely see that this is like a big problem that needs to be addressed more. I feel like it's not focused on, because it seems like every AI model that gets put out, it has bias already, which I know is taught based off the previous data that the company has itself, which means that the companies within themselves are biased already, because if their AI model is biased, that means the company itself is biased. So I think we definitely need to figure out how to move on forward from these biases so we can just create a fair and equal world for everybody.
Absolutely, yeah. Well. First of all, I'm super thrilled to hear that this is one of the big highlights of your semester, building that model and taking that challenge. And on top of that, I think one of the things that I'm really interested in, and I spoke to you and the rest of the students about, is like responsible AI. And I think these are hard problems, right? And so having a concept of responsible AI with how we build models and how we will address bias or choose the right algorithms that might expose that bias. Part of it's maybe just having a model development standard and a set of values, which is we're going to put explainability, interpretability, bias detection front of mind, right? And invest the time in it. And I'm hopeful, with folks getting more and more visibility to this, right? And then, processes that organizations put in place to take the time to really address it, like the time that you all spend on your models, right? You get to a better place. So, but complicated, and I think that's why many organizations do need a playbook, and then they have to enforce that playbook. There's a concept called auditable AI, which is specifically for that purpose. Which is, we all know that we want to build these models to be, explainable and interpretable and unbiased, but then we have to enforce, that they are, right? And in some sense, that's the policing policy to make sure that these models get built properly. All right, well, we're getting to the end of the time, and I guess for both of you again, right? Would you endorse or recommend this for other students to participate in a challenge like this, other college students?
Yes, I would definitely recommend other college students to participate in a challenge like this. Even if it's not your primary expertise or something that you're interested in, you're gonna gain a lot of knowledge and a lot of new skill set. A lot of us come from technical backgrounds, so we kind of had a lot of technical knowledge, but not more so so much about data science. As Dr. Pearson mentioned, is fairly new to Alabama A&M in our curriculum. So just for us, get this experience and, get the education that this is a real world problem. It definitely helped us gain some new skills and knowledge. So I would definitely recommend other college students to do a challenge like this.
Great. And DeTavein?
Yes, I would definitely recommend, if you want to just improve on your skills and try something new, because as a tech person, you should always be wanting to try something new, take on a new challenge, because the world is constantly evolving. the data science, it was tough for all of us because we've never done anything like this. So if we can do it, then anybody else can. And I would definitely recommend that they should give it a try.
Awesome. Thank you, guys. Anything else you wanted to bring up before I bring Dr. Pearson back?
No, sir.
I would just like to say thank you to Scott and the whole FICO team, for including us in this challenge and including Alabama A&M University. We definitely look forward to see, where we can carry our relationship in the future. So thank you, Scott.
Oh, it's my deepest pleasure. Thank you, guys. I appreciate it.
Thank
All
you.
right. Let's bring on Dr. Pearson. We'll wrap up. Well, hi, Dr. Pearson. This was a great conversation and just a really great way to end the program and to get these perspectives. As I mentioned, right, this is super important to me personally and to FICO also, right, just to have this sort of experience and work with teams and develop the next generation of data scientists. And I took away a lot from the perspectives, right, to see how the teams solve these problems and look at these problems. And so I want to thank you, Dr. Pearson and Dr. Zhao, for your support of this program. It's been amazing.
Thank you as well. This was a great opportunity for our students and the university, and we look forward to continuing our relationship in the future.
And I, excuse me, we most definitely will, because one of the things that I want to do is be a resource if you need, right? But in addition to that, we're planning in the fall to do the next generation of this challenge around fraud. It should be a really interesting problem to get the students to think about fraud detection and crime detection in terms of financial fraud. So hopefully we can work together on that and partner. So with that, yeah, appreciate it. Thank you, DeTavein and DeQuanda, and thank you, Dr. Pearson. Appreciate the conversation. Thank you.
Thank you.
All right. Bye.